The question says, for the arrangement shown below, find the equivalent circuit capacitance and voltage across a 4.5 microfarad capacitor. The first thing I want us to do is to label these capacitors. In labeling these capacitors, let's call this C1, C2, C3, C4. I'll tag this my C5 and C6. Obviously, you see that the C1, C2, and C3 are in series. C4, C5 are in series. Let's solve for the equivalent capacitance of the series circuits first. That means my C1, C2, and C3. Here's the 4.5, 4.5, and here's the 4.5 microfarad. Now 4.5 is the same thing as, I prefer to convert it to an improper fraction. It's the same thing as 9 over 2. Now 1 over C for this series capacitance will be the same thing as 1 over C1 plus 1 over C2 plus 1 over C3. I'll take the inverse of my 9 over 2, which is the same thing as 2 over 9 plus 2 over 9 plus 2 over 9. Now here is 9, 2 plus 2 plus 2, which is equal to 6 over 9. That's 1 over C. And so that C itself will be equals to 9 over 6, which is equals to 3 over 2. If C is equals to 3 over 2, that's the same thing as 1.5 microfarad. Let's solve for the second series capacitance, that's this. So here is my C4 and my C5. Obviously, my 1 over C here will be the same thing as 1 over 1 plus 1 over 1. That's, take an LCM of 1, you have 1 plus 1, which is the same thing as 2 over 1. So that my C in this case will be the same thing as half, which is equals to 0.5. So that for the whole of this circuit, I now have two capacitance. I now have two capacitance in parallel. I can now relate it this way to mean that this is 1.5 and this is 0.5. That effectively, for capacitance in parallel, for the parallel circuit, my C effective for that circuit will be 1.5 microfarad plus 0.5 microfarad, which is equals to 2 microfarad. Now, in case you missed our lessons where we explained capacitors in series and in parallel, please don't hesitate to check the description below. We'll place a link to that lesson, and I'll also use that link as lesson as our end card. You can check the end of this lesson to pick up that lesson. Now, so that the effective capacitance for this parallel circuit is 2 microfarad. Now, we can now redraw the entire circuit to look like this. Where this is a 2 microfarad and here is a 3 microfarad, and here's my source voltage of 500 volts. If you look at both of them, the voltage across this part, I would like to call it V1 because my second part of the question still wants me to calculate voltage. I'll call this V2. Now for the final effective capacitance, let's call that CE. That will come from 1 over 2 plus 1 over 3, which will come, here is 6, 2 in 6 is 3, plus 3 in 6 here is 2. That's 1 over CE, sorry, that's 1 over CE, will be equals to 5 over 6. So CE itself will now come from 6 over 5, which is equals to 1.2 microfarad. Now, if this is one, that's the total effective capacitance of the circuit. Now, let's take the B part of the question, which wants us to calculate, let's see it. It wants us to calculate the B part of the question says we should calculate the voltage across a 4.5 microfarad. That is, we should calculate the voltage across one of these circuits, one of these capacitors. That's the voltage across one of these. First, we'll be interested in the voltage across the parallel circuit, which we can easily calculate, which we have called V1. This we have called V1. And the voltage across this circuit, we have called it V2. That's what I have done here. Here's my V1, and here also is my V2. Now, if you look at this combination closely, you see that V1 plus V2 will be the same thing as 500 volts. Now, at the same time, 2 of V1 will be the same thing as 3 of V2. So that V2 is equals to 2 over 3 of V1. Let's call this equation 1, and let's call this equation 2. I'd like to substitute for V2 in equation 1. So that V1 plus 2 over 3 V1 now equals 500 volts. Now let's take an LCM of this. This 3, V1 in 3, that will be 3 times V1, that's 3 V1 plus 2 V1 is equals to 500 volts. Now, so that 5 V1 over 3 is equals to 500 volts. So that V1 effectively is equals to 500 over 1 times 3 over 5. 5 here is 1. 5 in 500 is 100. So that V1 is equals to 300. V1 is 300. That is the voltage across the parallel side V1 here is equals to 300 volts. Now, since the voltage across the parallel combination is 300 volts, that means the voltage across this end is 300 volts. And each of the capacitance we're given is 4.5, 4.5, 4.5. They are equal. So to calculate the voltage across each of the 4.5, you can simply divide your 300 so that voltage across the 4.5 microfarad will be equals to 300 over 3, which is equals to 100 volts. 100 volts. With this, we've come to the end of this worked example. I hope you understand how to calculate voltage across capacitance in series and parallel, and also how to calculate the effective capacitance across capacitance in series and parallel. If you have questions, please do not hesitate to use the comment section and share your questions with us. Thank you for staying with us, and do have a nice day.